All right, we should be on this page here, so if you're not there yet, go ahead and open up to this page. We're going to talk about another type of angles that we can see on our circles. Yesterday, we spent time going over how a central angle and an arc that it intercepts relate to each other. We talked yesterday about how central angles and the arcs that they intercept are congruent. So if you know one of the two, then you should be able to easily start filling in some of those missing pieces like we even did on our bell ringer today. Today, though, we're going to talk about something called an inscribed angle. So just look at this picture I have up here on the right. What's different about this angle and how it's drawn? What's different from yesterday? Like yesterday, you would have had it here. The vertex would have come from here, the center. What's this one doing? An angle. Where's the vertex at this time? How would you describe the location of this point?
It's a secant line.
Oh, it's kind of like a secant, right? Because it goes from like edge to edge of a circle. It doesn't necessarily pass through the center. The vertex, we would say, is maybe on the edge of the circle. Okay, so instead of it being from the center, like we saw yesterday with all those central angles, now they've pushed this vertex maybe back a little bit to like the edge of the circle. So that's what makes an inscribed different. It looks a little bit different, and that's going to lay into some of the differences that we're going to talk about later too with like its measurement. Okay, so let's go ahead and just write down the definition of an inscribed angle. An inscribed angle is an angle that has a vertex on the circle. So if I wanted to name this angle, I would say angle ABC is inscribed. If you think back with me, again, way back at the beginning of the school year, when we were doing stuff with like our constructions, we talked about inscribed shapes and how to actually do a construction. We inscribed a triangle, a square, and a hexagon. So we've talked a little bit about this idea of something being inscribed into another shape. So when they say it's an inscribed angle, it's going to be inside the circle still, but the vertex is going to be, like we said, on the edge of the circle. Now, the arms of the angle, like the two rays that make that angle, they're going to still intercept an arc. So you can even see on my picture here, where B is at the vertex, B goes down to A and B goes down to C. This arc AC is the intercepted arc, just like we saw yesterday. But remember yesterday we talked about the relationship between a central angle and an arc and how they're equal to each other. Let's talk about now what does this mean for an inscribed angle, because it's not going to work the exact same way. So on my next picture, I actually have both of the angles drawn on here. I have a central angle here by D, and I have an inscribed angle right there by B. These are two different types of angles, but if you guys look here, follow the sides of angle D. It goes D to A and D to C. Where do the sides of B go? The same points, A and C again. So they can possibly intercept the same arc. Maybe their vertex is from a different spot though. So if it's inscribed, instead of it being congruent like we saw yesterday, the measure of an inscribed angle is going to be half the intercepted arc and central angle. So think of it like this. If I had the central angle or the arc, like we did yesterday, if you have one of those two, then you automatically know what the other one is because they're congruent. So let's just say I know that angle D is X degrees. that means that this arc A to C would also be x degrees. Okay, if I know that those two match, how I would write it for the inscribed angle is it's half of that. Well, if you half something, that just means you divide by 2. So this angle up here I would write as x degrees divided by 2. And that would be your inscribed angle relationship. So another way they might write that would be actually using notation describing the angles and the arcs that we're talking about. So for example, if they wanted you to write out how does that angle, that inscribed one, the measure of angle ABC, relate to either the arc or to the central angle, we could say that it's half of whatever the arc measurement is. Or we could say that that same inscribed angle ABC is half of the central angle, which is angle ADC. So I can really use either one. I can use the central angle or I can use the arc that it intercepts, because we talked yesterday about how those will always be the same. Now, eventually we'll actually start putting in some numbers here and working with those. You'll also really want to make sure that as you're looking at a picture that you double check that you're going the right direction. Because sometimes they'll maybe switch this on us. Like at some point we'll kind of get used to going one way. Like they'll maybe give us the arc and we'll be like, okay, I got to divide by 2. Oh, here's another arc. Okay, I got to divide by 2. And then all of a sudden they're going to throw you a curveball and they're actually going to give you the angle and you need to find the arc. And if that happens, you reverse it. So if I wanted to know how much is this arc AC and I was given how much this angle is, you would just double it to get back to the arc. So just make sure, depending on what direction they want you to go, that you're using the right operation. Questions on that first theorem there? Remember, a theorem is just like a rule. Questions on that first rule? Okay, so let's take a look at the next one. Another theorem. This one is saying if 2 inscribed angles of a circle intercept the same arc, and then we need to fill it in. So let's just take a look at our picture here. I've got 2 different inscribed angles, B and D. Follow the sides of B and D. Where are they both going? A and C. So they are intercepting the same arc. What do you guys think that means about angles B and D then? If they're intercepting the same arc, they'd be what? The same. Yeah, so let's write that out. If 2 inscribed angles of a circle intercept the same arc, then they are congruent. So in this case, the measure of angle ABC would be equal to the measure of angle CDA. You can see they both have a C and an A in their name. D and B are the only thing that's changing because we're talking about a different angle, different vertexes. But because they have that same common intercepted arc, that's going to mean that those angles are going to be congruent to each other. So if you knew how much angle D was, you would be able to find out the measure of the arc, and you'd be able to find out the measure of that angle using the relationships that we've been talking about. Being able to know which ones would be equal, knowing that we maybe need to double a measurement to get to the arc, or again, if they gave you the arc, you would know how to find both of the angles there. Okay, we've got one more kind of rule to talk about, and then we'll get into some examples here. So this one says, if one side of an inscribed triangle is a diameter, then the angle opposite, and then we got to fill it in again. So remember, inscribed means it's a shape on the inside of the circle. If I have an inscribed triangle, the triangle is in the circle here. We can see that. We've got this triangle, EGF. Now they are telling us that EF is a diameter because it goes all the way across. If you know that this is a diameter, let's think about this arc from E to F. How much would it be?
180.
180. So this whole arc from E to F would be 180 degrees. Okay, from here all the way over. So how would you guys figure out how much G is if that's the inscribed angle? Half that. What is half of 180? 90. That's always going to happen. If you have a diameter and you're trying to go to the angle that's inscribed and it's hitting that diameter, it's always going to be half. So let's fill that in up here. We can say that the angle opposite is always 90. So I would say the measure of that angle EGF is equal to 90 degrees. You could also say that the triangle in there, EGF, is a right triangle. So that'd be another statement that we could make that's true. So if you see a situation like that where the intercepted arc is hitting the diameter, it's going to always be 90 degrees. I'll also say that there's going to be some problems on your worksheet today where some kids have been getting kind of stuck in first period where they see a picture but they don't maybe have enough information to find the arc or the angle that they think they need to be looking for. If there are triangles inside of your picture, you can use what you guys know about triangles to help you fill in some gaps. So what do you guys know about the angles in a triangle? They have to add up to 180. So even like on this case, if we knew how much G was going to be and they wanted me to find F, and I maybe don't have enough to go there right now, but maybe they gave me another arc on the picture, we could use some of that other additional information to kind of work to find something that maybe they're not asking for, but then use that information to help us get to what they do want. So keep that in mind. Some of these relationships like vertical angles, the stuff we know about triangles, those things are still going to play a part in some of the pictures that you come across today. All right, let's get into some examples now. So when you're looking at a problem, they might have angles or arcs that they want you to find numbered. They may not put like X's and Y's in there. So when I see this picture, the 1 and the 2 don't have degree signs next to them. So those are the angles that I want. I want angle 1 and I want angle 2. So I'm just going to go ahead at the very start before I even get into this. I'm going to just put up here, I need to know what angle 1 is, and I need to know what 2 is. I need to know what those are equal to so that I can solve the problem. Once I figure these out, I'm done. So now let's think about how we would do this. You know that that angle there is 38 degrees. What kind of angle is 38 degrees? From what we've talked about today and yesterday, is it inscribed or is it a central angle? Central. So how does it relate to this arc that it's intercepting? 38. It's the same, right? So we know that this would be 38, which means 2 up here is 38. That's a central angle. It's intercepting that arc. They have to be congruent. That's what we learned yesterday. Now, how about 1?
19.
How'd you get there, Hayden? Yeah, so because 1's sides, like here's my vertex for 1, it goes down to this, and it goes down to this. It's hitting that arc, that's 2. And so this is an inscribed angle, so it's half of that, which is where he got 19 from. So for this, I'll just write over here, we took 38 divided by 2. Or a half times 38. Okay, questions on that first one? Okay, let's go on to number 2. I want to, again, find 1 and 2. So once I have these filled in, I'm done. What do you guys see or want to do? Because why? Yep. Very good. It's a central angle, so it's going to be congruent to that arc. Great. How do we do 1 then? We have to half it. We have to take 114, divide by 2, because again, it's still hitting that same arc, but now it's inscribed. What is half of 114? 57. Good, 57. So very similar to the first one. All right, what about C? The last one here. I still want 1 and 2.
Is 118.
Is 118? Is that what you asked? Well, what kind of angle is the 18? Is this a central angle or inscribed? It's inscribed, right? So instead of them being equal, there's a different relationship here. You're saying we have to double it? Why do we double it this time?
Because it's the arc, and if it was from the central angle, it would be the double of it.
Okay, so we're finding the arc this time. This is what I was talking about a little bit ago, that they're going to maybe try to throw a curveball at you. We've been used to, from the first two examples, taking half of the arc, right? But now we are looking for the arc. So instead of taking this half, we want to actually double it. So what is 18 doubled?
36.
Good, so there's the 1, 36. All right, now I need 2. Anyone have thoughts on how we could work our way to 2? First thing I would maybe do, if you're not sure, is figure out what's the arc that angle 2 is intercepting. So if this is my vertex up here, and I come down on my sides, this would be the arc that I'm intercepting. Do we have that measurement? Mm-mm. Could we find it? What'd you say, Anna?
Is it 108?
How would you get here? Can you tell me what you were doing?
Would you do 100 plus 18 plus 134 minus 180?
Okay, so let's be careful with this one because this is the angle on the inside. I agree with the 100 and the 134 because those are on the outside. But how much did we say this was?
36.
36. So instead of using the 18, let's use the 36. So let's take 100 plus the 36 plus the 134. And what would we do with that number? Yeah, take it from 360. Because remember, a full circle is 360. I have everything on my circle but this piece. So let's use all of this to help me get this. It's 90. Okay, so this is 90. That means that this arc here is 90. So how much is the angle 2?
45.
Good, 45. You got to cut this in half. 90 divided by 2. So 45. So even on that one, it wasn't just like, here's the information, multiply by 2 or divide by 2 or see that they're the same. You might have to reason your way through. Use your information about how many degrees you know are in a circle. Use diameters if you can. Use triangles if you can. Vertical angles, all that stuff might play a part in these problems here. Yeah.
If you were to make the central angle, wouldn't that kind of look like a 90-degree angle almost?
It would, because if I were to connect this and then this, it would be a 90-degree angle in there. You're right, because it would have to equal.
So could you go off that, or do you still need to do it then? Because you don't know if it's a 90-degree angle.
Yeah, I would say you can't just assume. Like, you could draw in the central angle if you wanted to, if you felt like that would be helpful in like isolating where you're looking. But if they don't give us this number, we still would need to do this work to verify that it is 90. That's a good question, though. Yeah, we don't want to run into like any assuming. Okay, we did that when we were like proving things. We don't want to assume that something looks a certain way in our pictures. There has to be some kind of mathematical reasoning as to why we got there. Good question. Anyone else have questions about inscribed angles today? Okay, I'm going to get you guys your homework. You've got the rest of class here to be working on this.
You're getting moved for 5 minutes.